this set of snap circuit videos, we're going to look at projects 601, the alarm power, to project 622, the current flow. So, with project 601, alarm power, that's how it is in the book, and there it is on the board. So here we've got our 6-volt setup, and it's being limited by our 6-volt lamp running in series, and going to our slide switch to turn the whole circuit on and off. That has our regular D3 diode under the meter here, and that's feeding both our second and third inputs of our alarm IC. And then the output of the alarm IC is driving our motor here, but it's also driving our meter, so we'll see it deflect, and also our transformer, which is across both our green and red LEDs in opposite directions, so of course we'll see those pulsating as well. So when we turn the circuit on, we can see that our 6-volt lamp here is lighting up and pulsing with the alarm IC, and of course we can see that our LEDs are shimmering and flashing. They're shimmering because of the AC voltage being created by the spinning of the motor here, and then also flashing because of the output from the alarm IC there. And we can see that being reflected on our meter here, both the alarm IC and also the AC voltage being generated by our motor here. So we can see the meter deflecting some, but it's also, of course, not deflecting all the way back because the motor free spins when the alarm IC turns off momentarily, and that's how we still get some output here on our transformer. So that's how project 601 works, and now we're going to move on to project 602, which is alarm power 2, and for that we simply take the motor off, and when we remove the motor from the circuit, now we don't have the motor AC voltage being produced across our transformer there, because now it's strictly running off the alarm IC. And because of that, it's now pulsing at a slightly faster rate of about 1 hertz or so. And of course our LEDs are just flashing now, they're not shimmering. And our meter goes full deflection now. It's going from 0 up to about 6 or 7 and then back every time the alarm IC pulses. So that's how project 602 works. Now project 603, we're just going to take the whistle chip and replace it where we had our motor. So now we're going to hear more of the alarm IC output. So it still pulses at about the same rate or so as the previous project, but now with the whistle chip in place of the motor, we're now getting more audible output from the alarm IC. But of course the whistle chip does not behave like a motor, so it's not creating any kind of AC voltage across our transformer here. So that's how project 603 works, and now we're going to move on to project 604, which is the mega pulsar and flasher. So here we have project 604, the mega pulsar and flasher. There it is in the book, and here it is on the board. So we have our 6-volt supply going to our slide switch. Let's turn the whole circuit on and off. That then goes to a couple of things here. Number one, it goes to our PNP transistor, which is kind of situated under the meter here, and that is controlling the input on and off to our number 3 input of our alarm IC, while we have a constant supply to the number 2 input. So the PNP will be pulsing the number 3 input to our alarm IC on and off here. And then the output of our alarm IC is doing a couple of things as well. Number one, it's putting output to our whistle chip here. It also connects across our meter, so we'll see our meter deflect a little bit as it's pulsing on and off. It also drives our transformer here, and the transformer has a couple of bits going on as well. Number one, it's got both the red and green LEDs both in separate directions, so we'll see those pulse on and off with the output of the transformer there. It's also driving our 470 microfarad capacitor, which is going into the base of our NPN transistor here, and that is thus then controlling the supply to our 2.5 volt lamp, or 3-volt lamp and 6-volt lamp holders here. So these will pulse on and off with the on and off of the NPN transistor here coming off of our transformer, which of course is coming from our alarm IC, connected through our regular D3 diode here. And then on the ground side we have our motor, which is basically just pulling the whole side of the alarm IC down, reducing its output some. So there's quite a bit going on with the circuit when we turn it on. So we can hear our output from the alarm IC there as it's again being pulsed by our PNP transistor there. We can see the output from our meter there is hovering a little bit, but it's going back and forth as it pulses. Our motor is running constantly because it's not being affected by the pulsing here, because again it's just pulling the alarm IC's side down there. But we can see some pulsing of our LEDs here. We can certainly see the pulsing of our 3-volt and 6-volt lamps, which again is being controlled by our NPN transistor here from the output of our transformer. So that is how Project 604 works, and now we're going to move on to Project 605, the ENS blinker. So here we are with Project 605, the ENS blinker. There it is in the book, and here it is on the board. So here we've got our 6-volt setup with our diode going into ground, a regular one here. That is then feeding both the positive input of our 7-segment LED here, but also feeding the power input to our alarm IC, which is going to be used for the blinking later. Its output is then driving both the base of our NPN transistor here, along with being brought down some by our 100,000 R5 ohm resistor here. And the base of our NPN transistor also has our 10 microfarad capacitor with positive going toward the base of it. Then the output, or I should say our NPN transistor, is controlling one of the segments here on the 7-segment LED, and then of course we got another by our alarm IC there. And our 6-volt lamp here is just kind of acting as a voltage drop. It doesn't light up, but it acts as kind of a 3-snap for our 7-segment LED. So when we turn it on, it starts off with S and it alternates back and forth between S and E. And as our alarm IC output goes on and off, it controls the output to our NPN transistor, alternating between our one segment here and the segment on the other side. And by that we can get it to both switch between showing an S and an E on our 7-segment LED display. Now, I don't know if you noticed or not, but there is actually a mistake on this picture. Can you see the mistake? It's probably a little hard to see here. If you note where they have the snap wire here, the snap wire is actually supposed to be right here, because it says segment C is connected to the base of Q2 and the output of U2. But in the picture, they don't have it connected to C. They have it connected to G above it, like this. And if it's like that, the circuit will never work correctly. So if you're having trouble when you build this circuit, realize that this picture is not correct. It needs to be at that point on segment C for it to behave correctly. Yeah, it's another one of those oversights that ELENCO made when they made the manual. So we're going to continue on to Project 606, and that is the 2 and 3 blinker. So here we are with Project 606, the 2 and 3 blinker. There it is in the book, and here it is on the board. So again, it's similar to our last circuit. We've just rearranged where the segments are that are going to be lit up, while our NPN transistor controlling C and our alarm IC controlling E independently. So when we turn the circuit on, now it's alternating between showing us a 2 and a 3. Again, as the alarm IC switches and controlling our NPN transistor, we get that alternating segment between E and C here, where it will either show us a 2 or a 3 as the circuit operates. So that's how Project 606 works. Now we're going to move on to Project 607, which is the 9 and 0 blinker. So here we have Project 607, the 9 and 0 blinker. There it is in the book, and here it is on the board. Now, I'll admit that my red snap just recently broke, so I just stripped some wire off, so I'm just going to hold it where it needs to be. So again, like the previous projects, we're just changing positions on our 7-segment LED there, so when we turn the circuit on, it will now alternate between showing us a 9 and a 0 as our alarm IC switches our NPN transistor on and off there, changing the segments. So again, going from a 9 to 0, we don't have our 6-volt lamp here this time. Instead, we have our A1 antenna acting as a connection bridge. So that is how Project 607 works. And now we're going to move on to Project 608, which is the 3 and 6 blinker. So here we have Project 608, the 3 and 6 blinker. There it is in the book, and here it is on the board. So again, as usual, we just reroute some connections there for our 7-segment LED. We don't have our A1 antenna coil anymore, so when we turn the circuit on this time, it now alternates between showing us a 3 and a 6, again as our alarm IC drives our NPN transistor, turning the output of that on and off, controlling the B segment of our LED display here. So that's Project 608. So now Project 609, we're going to do lowercase c and uppercase C blinker. So here we are, Project 609, the lowercase and uppercase C blinker. There it is in the book, and here it is on our board. And as usual, we just change connections around on our 7-segment LED so that when we power the circuit up, it now alternates between a uppercase C and a lowercase c, again as our alarm IC turns on and off our NPN transistor there. So that's how Project 609 works. Now Project 610 has us look at the uppercase and lowercase O blinker. So here's Project 610, the uppercase and lowercase O blinker. There it is on the book, and here it is on the board. And so we just changed our connections around again in our 7-segment LED when we turn our circuit on. It now alternates between showing us a uppercase O and a lowercase o as our alarm IC and NPN transistor switch there. So that's how Project 610 works. So Project 611 is the B and D blinker. So here we have Project 611, the B and D blinker. There it is in the book, here it is on the board. So we've changed our connections around in our 7-segment LED. Give a wire there, and we turn the circuit on. Now as the alarm IC and NPN transistor switch, we now alternate between showing a B and a D on our 7-segment LED. So that's how Project 611 works. And now Project 612 is an H and L blinker. Here we have Project 612, the H and L blinker. There it is in the book, here it is on the board. So again, reconfigured our 7-segment LED. When it's turned on, it now alternates between showing us an H and an L as our alarm IC and NPN transistor switch on and off. So that's how project 612 works. Now project 613 is the A and O blinker. Here we have project 613, the A and O blinker. There it is in the book, and here it is on the board. So as before, we change our connections around on our 7-segment LED, so when we turn on the circuit, it now alternates between showing us an A and a 0 as our alarm IC and NPN transistor turn on and off. So that's how project 613 works, and I'll show another example where they made a little bit of a mistake. You probably see they got a red jumper wire on here. That red jumper wire is unnecessary because it's just connecting across these points of the number 4 snap. It doesn't do any good having it there. Anyway, we're now moving on to project 614, which is the open and closed indicator. And here's project 614, the open and closed indicator. There it is in the book, and here it is on the board. So we have 6 volts, and we have our slide switch turning the entire circuit on and off. That is feeding our photoresistor, which is then controlling the base of our NPN transistor here, along with our 10,000 ohm resistor, dropping it across here. And we also have our R5 100,000 ohm resistor going into our NPN transistor there to control it. And so when we cover up our photoresistor, that will change how much current is getting to the base of our NPN transistor there. Thus it will change how we have some of the segment turned on or off. So when we turn the switch to on, it displays an O because there's light coming into our photoresistor there, and that's turning on our NPN transistor. Now if we close up our photoresistor, now we're taking current away from our NPN transistor, thus it's not turned on, so the segments on this side do not light up, and thus it leaves us with the letter C to mean closed. And we let the light back in, our transistor turns back on, lighting up these segments, and now we get O back on there. And you see, because if it's a photoresistor, we can vary the amount of current there, so we can almost make it still turn those 2 segments on by just changing the current a little bit. So that's how project 614 works. And now we're going to move on to project 615, which is the open and closed indicator 2. So here we are at project 615, the open and closed indicator 2. There it is in the book, and here it is on the board. So this time, instead of our NPN transistor, we have our U4 amplifier IC, and it's going through our 10,000 ohm resistor to our press switch, which is feeding one of its inputs here. And then its output goes to our green LED and then to the segments on our right side of our 7-segment LED. So when we turn the circuit on, it normally displays a C there, which is a little bit blocked by the number 4 snap there. But as we press and release the press switch, it momentarily changes to an O and lights up our green LED as the output voltage on our amplifier IC changes there. And actually we can even use our finger to make it more constant, because we can act as a ground or a signal for the amplifier IC to use. And if I just kind of wiggle the push button there, I can kind of get it to go on and off like that too. So that's how project 615 works. Now project 616 is the vibration indicator, and for that we're going to take our press switch away and replace it with the whistle chip. And by doing that, we'll use the whistle chip as sort of a switch by tapping on it to change the signal on our amplifier IC. So as we tap the whistle chip, our green LED lights, and we also change the output segments on our 7-segment LED there. And again, the harder we press the tap, the brighter, of course, our LED gets along with that. Or if we tap it very softly, we tap it very softly, we can change that. So of course it gives a slightly varied output by doing that. So that's how project 616 works. So 617 is our vibration sounder. So here is project 617, the vibration sounder. There it is in the book, and here it is on the board. So we have 6 volts going to our amplifier IC, also driving our motor, then going down through our 6-volt lamp, and then back through our slide switch. While we also have our whistle chip going through the motor, through R4, and then back to one of the inputs on our amplifier IC. And then that amplifier IC output is going to our green LED, and then also through our speaker that's being limited by our 100 ohm R1 resistor. So when we have the circuit powered up with the fan off the motor, our green LED lights up briefly there as the motor starts up, and it says it's spinning. Our 6-volt lamp is dim because of the high back EMF on the motor there, and we can hear that coming through our speaker there from the output of our amplifier IC. Now if we put the fan on our motor, again we briefly get our green LED lit up there. We can again hear the motor through our speaker, but it's different now because it's turning at a lower RPM. Put the fan on there, and because there is a load on the motor, having slowed it down now, our 6-volt lamp is a lot brighter, meaning there's more current going through that part of the circuit there. So that's how project 617 works, and now we're going to look at project 618, which is the SCR Noise Circuit. So here we are, project 618, the SCR Noise Circuit. There it is in the book, and here it is on the board. So we have again 6 volts feeding our slide switch, which is then going to our amplifier IC. We also have our motor being powered, and again going through our 6-volt lamp. Then we also have our whistle chip providing some input being lowered by our 10,000 ohm resistor into our amplifier IC, and we're getting our motor input being heard again through our speaker, and we have our green LED also on the output of our amplifier IC. The big change this time is we have our silicon controlled rectifier, or SCR, controlling the flow of the circuit here. So when we turn on the power, nothing on the circuit happens because the SCR gate has not been triggered on there to allow current to flow. When we press the press switch, it gives a small boost of current to the gate that turns the SCR on and now allows current to flow through our circuit. And because of that, our motor spins up, our 6-volt lamp glows, we can hear the motor through our speaker, and our little green LED lights up. Now if we press and hold down the press switch, the noise from the motor gets louder from the speaker, and our green LED goes off. And the reason for that is because when we hold down the press switch, we're actually using the gate of the SCR here to provide some more current passage through our amplifier here back to ground. But as the SCR stays triggered, the circuit stays going. Otherwise, when we turn the power off and back on, it resets. So we have to trigger it again with the push button. So that's project 618. So project 619 is the SCR and Transistor Switch. So here we are at project 619, the SCR and Transistor Switch. There it is in the book, and here it is on the board. So we have our 6 volts going to our slide switch. That's feeding our press switch. And then we have our 5.1K resistor going into the gate of our SCR, which is connected across our 6-volt lamp. And then our press switch is also feeding our NPN transistor's base through our 1000 ohm resistor, which is connected across our 2.5-volt lamp, and then going back through our speaker. Then when we turn on the circuit, obviously nothing happens until we press the press switch. When we press the press switch and hold it down, both our 6-volt lamp and 3-volt lamp light up. But when I release the press switch, the 2.5-volt 3-volt lamp here goes out. but our 6-volt lamp stays on. And that's because we've triggered the SCR, so our 6-volt lamp stays on, but without a continuous supply to our NPN transistor's base here, our 2.5 volt or 3-volt lamp here will not light up until we hold down the button. And then that provides a feed to our NPN transistor. So that's how Project 619 works. Now Project 620 is the 2-speed motor, and for that we're going to modify our circuit a little bit here by including the motor down here. So let me take this away, put our motor here, complete with the fan. And then let's see how we're going to do this. Do that, this, and this. So now when we power up the circuit, again, nothing happens, but we can press and hold the press switch, and both our lights light up there and our fan comes on, and we can actually hear it through the speaker there. But when I release the press switch, the motor actually slows down, and if we press and hold it again, the motor speeds back up. And the reason for that is because we're connecting the lamps now in series with the motor here. So when we have just the 6-volt lamp here, we only get so much current through the motor. But when we allow the 3-volt lamp to come on here through the NPN transistor, we can actually allow more current to flow through the motor. And because of that, the motor ends up speeding up now that we've got more current able to go through it by having both these circuits active. When we have just this one circuit active, there's only so much current that can go through the motor, which is why it runs slower. So that's how Project 620 works. And now we're going to move on to Project 621, which is 2-speed motor 2. So here at Project 621, the 2-speed motor 2. There it is in the book, and here it is on the board. So it's a little different from the previous project because instead of having the motor in series with both of these circuits, the motor is now actually in parallel because now we have these working together. So when we turn the circuit on again, nothing happens. When we press the press switch, the motor starts up and our 6-volt lamp glows dimly because it's in series with the motor. But when we press down the press switch, our 3-volt lamp now is nice and bright because it has its own pathway back to the battery. Again, it's running in parallel with the motor, not in series with it this time. And because of that, the voltage drop this induces slows the motor down some when you press the press switch, as opposed to before where it actually sped it up because it provided more current to the motor. In this instance, it's actually dropping across the motor, so it's actually going to slow it down some being in parallel. So that's how Project 621 works, and now Project 622 is current flow. So here we are, Project 622, the current flow. There it is in the book, and here it is on the board. So this time I'm using the battery packs because of how this circuit operates and what we're trying to demonstrate. So we've got pretty much 3 independent circuits happening here. We have a press switch that when we press it uses this battery pack to connect our 6-volt lamp and our motor along with our meter to measure current. And then if we use our slide switch down here, then we connect our 2.5-volt lamp with our motor and our meter, but it's going in the opposite direction, which we'll see from the fan. And then if we use both of these, well, then we connect these battery packs together in 6 volts, just powering our 2.5, 3-volt lamp and 6-volt lamp. So when we turn on the slide switch, our motor spins up in one direction and our 3-volt lamp there glows dimly because it's in series with the motor. And we can also see some current flowing through our meter, which is being limited by our 5.1K resistor. If I press the press switch, you see the motor starts turning in the other direction, and we actually have negative current on our meter there, because you see it's trying to deflect that way. And our 6-volt lamp glows dimly this time, because again it's still connected in series with our motor. Now if I have the slide switch on and I had the press switch held down, no current flows through our meter and no current flows through our fan motor, but our 6-volt lamp and our 3-volt lamp glow pretty bright there, because now the batteries are hooked up in 6 volts and we've got it flowing in this loop here through both our lamps. So that's how Project 622 works, and that concludes this set of Snap Circuits videos.